Hi guys, welcome to my video on creating a neural network from scratch. And so in this notebook, we're going to build a neural network from scratch, and we're going to see how it performs our predictions using forward propagation. So remember that all deep learning libraries have this entire training and prediction process already implemented. So realistically, you won't be creating a neural network from scratch, but this is going to help you to understand neural networks and how they work even better. So first, what we're going to do is go over neural networks, a brief introduction, very brief, very basic. Then we're going to initialize the network. Then we're going to compute the weighted sum at each node. Then we're going to do the node activation, and then we're going to use forward propagation to get a value. So here's a neural network. It has two inputs, x1, x2. It has 6 weights, w1 through w6. It has one hidden layer with two nodes, z11 and z12. It also has the biases for that hidden layer, and then it has an output layer with one node, Z2, with a bias B2 for that layer. And so what we're going to do is randomly initialize the weights and the biases for the network. We have 6 weights and we have 3 biases. So what we're going to do is import numpy as np. We're going to use the seed function. I always prefer to use the seed function because it allows you to reproduce your code. So we're going to run this. What this around function does is it just makes sure that each value has a certain number of decimal places, and we're using 2 decimal places for this. So we're going to run that. We're going to print our weights and biases, and there you have it. There are our weights and biases. Now, when we go to access these, we're going to use the 0th index because Python uses 0 indexing. So the first one, value w1, weight 1, is going to be weights 0. So it's going to be the 0th element in this array. And so what we're going to do now is run our x1 and x2, which are our input values. So we have those. Let's start by computing the weighted sum. So the weighted sum is very simply just, so you have the weight times the input value, so w1 x1 plus w2 times x2 plus the bias, is all that is going to give you z11. And so we're going to run that. And here we have it. The weighted sum of the first node in the hidden layer is 1.327. Next, what we're going to do is z12 weights 2 times x1 plus weights 3. So this is the third weight. This is the fourth weight. So the third weight times x1 plus the fourth weight times x2 plus the second value for the biases. And what this is going to do is return our second weighted sum. Now what we're going to do is apply an activation function. And the reason for this is that this allows you to get your output value again. So you're going to get the output value z, you're going to apply the activation function, and then you're going to use that to get your next output value. So the activation function takes this z11 as an input, and it takes this z12 as an input. So the activation function is going to give you another value, which is going to be your new input value that we're going to multiply by w5. So a11 is essentially going to be our new x value. So it's going to be this times the weight plus this times this new weight times the bias. And that's going to give us our output value here. We're going to then apply that to that activation function again, which is going to give us our actual value. And so what we're going to do here is we're going to run this to get our activation value, and it's 0.7903, and then we're going to get the other one, A12, and then we're going to get Z2, which is going to be the output value. And what we're going to do is we're going to take that Z2 value and we're going to apply it to the activation function again, which we use the sigmoid function in this case. It's a very popular function. It's just 1 divided by 1 plus the exponential of the negative value. And so now neural networks, so now we're going to actually initialize the neural network. Obviously, neural networks for real problems are composed of many hidden layers and many nodes. So this would be very inefficient to be doing this all from scratch, creating thousands of neural networks and layers and nodes. It would be a lot to do by hand from scratch. So we're going to do a very basic one where we have 2 inputs, 2 hidden layers, the number of nodes in each hidden layer. So we're going to have 2 nodes in each hidden layer. and then we're going to create the number of nodes that it outputs, which is going to be 1. So we're going to run that. And then now, once we define the structure of the neural network, we can actually implement it using the numpy library. So once again, import numpy as np, use np.random.seed to allow you to reproduce the code. The number of nodes is going to be n, the value we defined here, so it's 2. The network, so we're going to create an empty dictionary to actually see what the network looks like. And I'm not going to go through all this code line by line. I have some comments in here that will tell you what the code does, and I'll leave a link to the Jupyter Notebook in the description so you can download it and play around with it on your own. So what we're going to do is we're going to run this. It's going to print our network. So you're going to see your layer 1 here. You're going to have your node, the weights, the array. This is the actual array of the weights for that first layer, for that first node in the first layer. And then you have your bias as well. Weights again for that second node in the first layer. So you have 2 nodes in the layer. You have multiple weights also in that layer. Remember, on our first one, we had W1, W2, W3, W4. And for node 1, you had W1 and W2. And then for node 2, you had W3 and W4. So that's what this is doing. It's printing out the entire structure of the neural network. So what you can actually do is you can draw this out by hand if you really want to see and understand it a little bit better. I recommend doing that. It will allow you to get a good visual of what the actual neural network will look like. So next, what we're going to do is we're going to run this again. So we have what we just did. We created the actual structure of the neural network. We created our layers, our nodes, etc. Now what we're going to do is we're going to actually initialize the neural network. So once again, I'm not going to go through all this code line by line. You can go through it on your own. I'll have a link to the Jupyter Notebook in the description. So what we're going to do is run that. It's going to return the network. And now we actually have the ability to call this function and create our own neural network based on whatever parameters we want. So we have the parameters number of inputs, number of hidden layers, number of nodes, and number of nodes that we're going to output. So what we're going to do is we're going to initialize our neural network, right? So we have 5 for our inputs. We have 3 hidden layers. So we have 3 nodes in the first hidden layer. We have 2 nodes in the second hidden layer, and we have 3 nodes in the third layer. And then we have 1 node for the output layer. So we only want 1. So we get 1 output value. And now what we're going to do, so we can run that, and it generates that neural network called small network. And now what we're going to do is compute the weighted sum of these values. So this is another function that we defined. We're going to import numpy as np. We're going to use a random seed. So we're using 12 here. And inputs equals np.around, np.random.uniform. So here we go again. We're creating our input values. And we're going to run that. So here are our input values. We have 5 input values. Because remember, when we just created that small network, it takes 5 inputs. So we need 5 input values. So now what we're going to do is create our node weights and our node bias. Well, you can just view that. This is essentially what we're doing. So we're looking at the node weights and we're looking at the node bias, and we're going to run this. And then we're going to compute the weighted sum for that. So here we have our node weights. We have 5 weights. We have 1 bias. And then we're going to run the next thing. So we're going to get into node activation next. And what node activation does, we define node activation of the weighted sum. It returns 1 divided by 1 plus np of the exponential minus 1 times the weighted sum. So what this is doing is it's running our activation function, specifically the sigmoid function. This is the sigmoid function right here. 1 divided by 1 plus the exponential of minus that weighted sum. So when we run that, that's going to create our function. And then what we're going to do is we're going to actually use that function. So we're going to get the output of the first node in the hidden layer. And that's what that does. And so what we can do is we can forward propagate this and do this for an entire network. So we're going to run this function. I'm not going to go through all the code. I'm going to run it. So what we do is we start with the input layer. as the input to the first hidden layer. We compute the weighted sum at each of the nodes of the layer that we're working on, compute the output of the nodes of the current layer. Then what we do is we set the output of the current layer to be the input to the next layer. So what we do is our hidden layer uses the previous outputs, which were our first inputs from the previous layer. So essentially what we're doing, if you look at this version of the neural network, right? So this layer here takes this layer as inputs. If we had another hidden layer right here, imagine there's just another hidden layer here. This layer becomes our new inputs, and then we use these new inputs to create our new layer. And we continue doing that down the line until we get to our output value. And so what we're going to do next is we're computing the node activation. So we're going to run this to forward propagate. And then once we do that, we can use forward propagate to create our predicted values. So we run that. And what it does is this is going to give us all of our outputs. So the outputs of the nodes in the hidden layer, number 1. So these are our outputs from that. Since we did one that was 3, 2, and 3 when we created our neural network. So we're going to run this on a small network. And then here we can run this np.random seed my network equals initialize network, and we're going to print out the entire neural network to see what it looks like. Once again, you can take all this and you can draw it out by hand to get a real understanding for what it looks like. So now for a given input, using a random input, we're going to print our inputs and we're going to run this, and then we're going to take these inputs and we're going to actually run the neural network. So we're going to run it, and now we have outputs in layer 1, outputs in layer 2, outputs in layer 3, and then the predicted values for the given inputs. So feel free to play around with this code. That's all we have for today. I mean, the code is a little tricky. It's a little tough to understand. That's why I recommend you draw these out. Because if you draw these out, it'll give you a really good understanding of what the neural network looks like. You put the weights in, you put the biases in, you put the input values in. And when you run all that, you'll get a better understanding for what a neural network is and what it's actually doing. And so that's all we have to do for this video today. Thanks for watching. Please consider subscribing. That's all.